Okay, girls, this would be lesson number 2 on coordinate geometry of a circle, and it's based on the equation of a circle with centre HK and radius length R. So this is obviously where the centre of the circle is not 0, 0. So up until now, you were told that if the centre of the circle was 0, 0, or what went through, say, the origin, that the equation of the circle would be of the form x squared plus y squared is equal to r squared. In this case, the centre is HK and the radius length is r. Okay, so HK could be any kind of coordinates, and the formula that you use is x minus h all in brackets 2 squared plus y minus k all in brackets 2 squared is equal to r squared. So what we're doing is we're finding the centre and the radius length of the circle. So we're given this equation, right? So what you look at is you need to work out HK, you need to work out R. So the first thing I would do is put down my formula for the equation of the circle with centre HK. Directly underneath it, let's put down the equation that's given. So what we're doing is we're looking at what's corresponding here, because x equal to x, y is equal to y, and then what's corresponding here. So the first thing I'd put down, I'd say minus h is equal to minus 5. Now remember, it's h, that's the centre. So minus h is equal to minus 5. So really then the two minuses will cancel and you get h is equal to 5. And then minus k is equal to 3. So really then that's k is equal to minus 3, just brought the sign over to the other side. And then r squared is equal to 25. So r is equal to square root of 25, which will give me 5. So really then we can conclude that the centre of this circle is 5 minus 3, because it's HK, and the radius length is 5. Okay, so you can take that example down. The second example is where you're finding the equation of the circle, which has a diameter with endpoints 2 minus 3 and 6 minus 8. So at this point then you kind of know, or remember the characteristics of a circle, right? The circle has, the chord or the line that's going to the centre is the diameter. So half the diameter would be the radius length if you think about it like that. But also, wouldn't the midpoint of the line be the midpoint or the centre of the circle? Okay, so that's the first thing that we're going to do. We're going to work out the midpoint of the diameter, which will actually give me the centre. So I'm going to use my formula, taken from my formula and tables book, marking x1, y1, marking x2, y2. I always mark them in, okay, put them above it. Fill it in, we get the centre to be 4 minus 11 over 2. Now, the radius of the circle is the distance from an endpoint of the diameter to the centre of the circle, right? So what you could do is you could work out the distance between these 2 points and half it, which is what we're going to do, or else you could work out the distance from the centre to the one of the endpoints, and that would give you the radius, okay? So the radius is going to be equal to half the diameter is what they're doing here, but both sections will work for you. And you're substituting in, so again, use x1, y1, x2, y2. Substitute into your distance form, which is got from, and I'd write down the formula first of all before I substitute in anything. You get half of the square root of 41. So then what we're doing is we're putting down x minus h all in brackets b squared plus y minus k all in brackets b squared is equal to r squared. Isn't this my h? Isn't this my k? Isn't this my radius? So you're plugging it in, right? So you've got x minus 4 plus y, all in brackets squared, plus y plus 11 over 2, all in brackets squared, is equal to the square root of 41 over 2 squared. Okay, so if you square that, obviously the square root disappears on top, and obviously you're squaring what's underneath. And you can leave it in that form as well, that's fine. Okay, if the equation, a note to take down, if the equation is in the form x minus h all in brackets b squared plus y minus k all in brackets squared is equal to r squared, you just change the signs of the numbers inside the brackets to get the centre of the coordinates. So for example, x minus 2 all in brackets b squared plus y plus 3 all in brackets squared is equal to 50. So the centre of this circle is 2 minus 3. And literally you can just see what's the sign in front of 2. It was minus, so just change that to positive, and what's the sign in front of 3 inside the bracket was plus, so you just change that to a minus. So that's a good little kind of tip as well. Okay, another example then. So find the equation of the circle having the lines y plus 4 is equal to 0 and y minus 2 is equal to 0 as tangents, and with its centre lying on the line 2x plus y is equal to 4. Okay, so let's have a look at this then. Right, so what we'll do is we'll sketch the lines y is equal to 2 and y is equal to minus 4, right? If you think about this, this just changes. If you want to make it, if you had to draw this line, that's really y is equal to minus 4. So isn't y equal to minus 4 down here? and is in y equal to 2 up here. And remember, it says that they're tangents to the circle, and the centre of the line, with its centre lying on the line 2x plus y is equal to 4. So I'll draw a little sketch, right? Sketch the lines, and 2x plus y is equal to 4. So how you sketch that is you could do let x equal 0, let y equal 0, and draw your line, right? Find out where they cross the x and y axis and easily just join up the two lines. So it says the centre of the circle lies along the line y is equal to -1, right? So centre of the circle lies along the line y is equal to -1, because you can see that there's 1, 2, 3, 4, 5, 6. So 6 boxes. So let's go up 1, 2, 3. It's going to be going through here. So the centre actually lies along the line y is equal to -1. Okay, so that's the first point. Okay, and also along the line 2x plus 4 is equal to 4. 2x plus y is equal to 4, right? And that's given. So it lies on that, and it lies along the line if we were to draw that. So therefore the lines, or the centre, lies on the intersection of the lines y is equal to -1 and 2x plus y is equal to 4. So it's like if we were to think about finding the point of intersection, that would be here, and that would actually be the centre. But obviously we have the coordinates of the y, which is -1, but we need to find the x. So what we'll do is think of your simultaneous equations. You're substituting y is equal to -1 into the line that's drawn, the blue line. 2x plus y is equal to 4. Substitute in, you get x is equal to 5/2, and that is the centre. So the centre x coordinate is 5/2, and obviously the y coordinate is -1, and that's easily read from the graph initially, but we had to work out x. So the question was, find the equation of the circle having the lines y plus 4 is equal to 0 and y minus 2 is equal to 0 as tangents, and with its centre lying on the line 2x plus y is equal to 4. So it's always good to do a little quick sketch for a question like this. You could just draw the circle, like basically the way it is, right? Like don't make it too big, but obviously you know that's going to be in between these two lines. So if you think of the distance between these two lines, the half of that is going to be the centre, and that line lies on -1. So obviously you can mark in your coordinates here, mark in some of your coordinates here. Do a sketch of the line. Remember, to draw a line, you need 2 points on the line. So you could use the rise over the run for this, or you could just say let x equal 0 and solve for y, let y equal 0, solve for x, and you'll get 2 sets of coordinates. Okay, and what we need to do then, that was the centre. So you need to get the radius then, right? So that's just the centre that worked out there, and it asks you for the equation. So the radius length of the circle is the perpendicular distance from that point to y is equal to 2, right? So if we think back here, we don't know exactly how far the circle goes out. So that's why I was saying to you, you could draw the sketch as much as you want, but we do know that the distance from the point here to one of these lines, the perpendicular distance, because it would form a right angle, would be equal to the radius. So the radius length of the circle is the perpendicular distance from 5/2 to y is equal to 2. So really the radius length is just going to be 3. And like how we work it out is you could actually read it from your graph, like you could do it, or like I suppose if you think it's only y is equal to 2, right? So it's not exactly a line that's just sketched or drawn. We were able to mark that on our graph here. So that, like if you think of -1 all the way up to 2 is 3 units. -1 all the way down to 4 is 3 units. So that's why they get the radius to be 3. So therefore the full equation then is x minus h all in brackets squared plus y minus k all in brackets squared is equal to r squared. Is in this h, is in this k. So you'd have x minus 5/2 all in brackets squared plus y minus -1, which becomes +1 all in brackets squared, is equal to 3 squared. Simplify it then finally to x minus 5/2 all in brackets squared plus y plus 1 all in brackets squared is equal to 9. And that is finding your equation of the line by being given, say, intercepts on the y-axis and the x-axis. Okay? And that's the last example, so I'm going to give you a few questions then to try on that.